sun right from your home or terrace. Yes, you heard it right. And that through using a very simple instrument made up of used cardboard. So I'll tell you how to make this instrument first, and then I'll tell you how we can go about the observation part. So here you see this is one strip. Again, you need a hard cardboard so that it has a good support. It stays like that. And then you need two simple pieces of paper. One such paper is going to act as a screen and the other will act as a pinhole. So you can see that I have, made a tiny hole which is going to act as a pinhole. So this is a very simple way to make this instrument, and you can readily get the materials available at your home. Now let's see how to observe. Okay, so let's start with the observation. But before we start our observation, there's one caution that you need to keep in mind, and that is never look at the sun through the naked eye. Okay, so now in order to begin the observation, you have to keep the pinhole side towards the sun so that you get an image onto the screen. So you have to come a little closer to see the image. So this is the image of the sun that you see here, and you need to hold the instrument a little steady so that you can mark the size of the image. All right. So this is how you have to take, different sizes of the image. To reduce the error, you will have to take about 15 to 20 observations and then average it to get the mean size of the image of the sun. So from observations, you get the mean size of the image of the sun, and there are other parameters that we'll be checking in order to get to the diameter of the sun. So now that you know what are the other parameters required to measure the diameter of the sun, and you also know how this instrument works, I think you can definitely try to make this instrument and take the observations and get that thrill of measuring the diameter of the sun right from your home. Thank you. So this demonstration is to understand the phases of the moon. But before we understand that, I wanted to revise few basics. The first point is that moon does not have its own light, but it shines because of the reflected sunlight. The second basic thing that we need to know is that Earth and Moon both have two kinds of motions, the revolution and rotational motion. Now, the different phases of the Moon, the eight phases of the Moon that we see, are due to the rotational and the revolution motion of both Moon and the Earth. And I shall demonstrate that to you. So, for this demonstration of the phases of the Moon, let's consider this as the Moon, the bulb as the Sun, and I as the Earth. So let's begin with the first phase. This is the new moon phase. This is the crescent, the first quarter, gibbous, the full moon. Again, this is the waning gibbous, the last quarter, waning crescent, and back to new moon. So you see the revolution as well as rotation of Earth and the moon gives us these eight phases of the moon. Now let's see the different phases of the moon through this model. The phone flashlight is acting as the sun, and the ball inside is the moon. Now let's see the different slits. The first slit we are considering is the new moon. So you can see the new moon phase. Then we move to the next phase, that is the waxing crescent. See nicely here. Then we have the next phase, that is the first quarter, as you can see. Then we have the waxing gibbous, seen beautifully here. And then through this slit where there is flashlight, do you know which phase we'll see? Yes, it's the full moon. The other side of the model has the waning phases. I think if we make such models, it will become interesting for kids to understand the different phases of the moon, and the model is also very easy to make. I hope you liked the demonstration as well as the model. Thank you. Now let's see how to make this simple model. It has three components. The first one is a strip of paper which has eight slits with the different phases named beneath each slit. Then you have the second component, which is the flap, and the third component, which is this ball, which will be our moon. All you have to do is mark all the 8 phases properly in an order. Fold this. You can use a sellotape, paste it properly. This should be more over a circle, and then put this flap on. So now you have the moon which is hanging inside there, and you have to keep your flashlight or a torch on this slit, that is the new moon, and start observing the different phases of the moon. I am Karuna and I will be demonstrating Bernoulli's principle. Bernoulli's principle, in very simple terms, simply tells us that high velocity will always be followed by a decrease in pressure in that area. Now, Bernoulli's principles had applications in the building of planes. So, the airfoil is designed in a way that it can give the lift and allow the airplane to fly in the air. Next, I would give you an interesting daily life example. It is the yellow line that we see on the platforms. So, there, the line is actually there because of the Bernoulli's principle. Now, when the train is moving with a high speed, what happens is in the vicinity of that train, there is a low pressure area created. So, if you go across, you go inside the yellow line, then there is a possibility that you will be pulled towards the train and there could be a fatal accident. Now, I'll be demonstrating Bernoulli's principle using two simple, pieces of paper. So let's consider that if I am blowing the paper from this side, what will happen is the paper will go this side, right? And the other paper, if I'm blowing it from this side, it's going to go this way. So let's see, it goes outways. Now, a question to you. What will happen if I hold the papers like this and if I blow the air between it? Some of you might have guessed the papers may go this way, outside. But let's see what actually happens. So I hold it here and I'm going to blow air between the papers. Did you see that? So the paper actually stuck to each other. They came close to each other rather than going outwards. I'll do it again. Yes. So why does this happen? It happens because there is a high velocity wind that I'm blowing in this region between the paper. So the region between the paper becomes low pressure and the outside is high pressure. Now anything, any object would always tend to go from a high pressure to a low pressure area. And that's the reason why this is high pressure, this is high pressure, and the between is the low pressure. So the paper tends to go from high pressure to the low pressure, and that's why it sticks. So this was a simple demonstration of Bernoulli's principle used in airplanes, as I said. So the airfoil is made with a different kind of shape, right? What happens there is that the velocity of the wind is higher on the above, creating a low pressure above, and the velocity of the air is low, creating a high pressure. So the airplane gets a lift from high pressure to low pressure, and that's why airplanes can fly. I hope these examples and the demonstration made it easier for you to understand what is Bernoulli's principle. Thank you.